Hello, hello. So I've got chatting with quite a few folks today about how you're using ClickHouse, and it seems that there's a lot of motivation to start using AI and ML with ClickHouse, and that's exciting. We've just developed a new team around this. Alexei demoed our agent, which we'll be looking at again. And as Dale mentioned, we know that no startup conference in 2025 is complete without some sort of AI strategy presentation. And that makes sense because VCs have invested hundreds of billions of dollars into AI in the past few years, and the ecosystem is growing faster than anything that most of us have ever seen before. We really like the word ecosystem here because, for the most part, we can divide it into two separate systems. Those that are producing AI models and those that are consuming their outputs to create AI-powered products. And at ClickHouse, we found ourselves in somewhat of a unique position. We know that LLM providers are using ClickHouse to train and observe their models, while AI-powered services are using it as a data layer to store and retrieve data for their agent-facing analytical experiences. And today, I'm excited to share some of the work we've been doing and new features we've shipped to help our users and the next generation of AI products get even more out of ClickHouse. So the first one I'd like to highlight is user-defined functions. So UDFs, of course, can be written in SQL, but for more complex tasks, they can also be expressed in Python or other programming languages. For AI and ML workloads, this is quite a big deal because it opens up a direct communication channel with third-party APIs and models, including LLMs. A common example we've been seeing internally is generating embeddings directly from SQL. And while UDFs have been in the ClickHouse open source distributions for quite some time, we're excited to announce that this is now finally in private preview as part of the ClickHouse Cloud experience. And of course, generating embeddings is great, but what about storing and searching them efficiently? Until now, what we've really been missing is a fast, scalable similarity index. And I'm excited to share that this is now generally available in ClickHouse, powered by HNSW. It supports both Euclidean and cosine distance metrics, enabling high-performance approximate nearest neighbor search right from inside ClickHouse. Now, putting these two pieces together, we can now generate embeddings on the fly, and at prompt time, applications can use vector similarity indexes to retrieve relevant records and perform analysis. This powerful combination unlocks a whole range of AI applications and lowers the bar significantly, from RAG pipelines to recommender systems. And in short, this integration bridges AI workloads with traditional analytics, letting you move seamlessly from raw data to intelligent retrieval and insight, all from within ClickHouse. And when we talk to our users while we're building these new features, we're understanding how people are using ClickHouse right through the ML lifecycle. On the left, it's about exploration and preparation, the data science side of things. So we've got ClickHouse Local for more ad hoc analysis, and for more complex, beefier analysis, there's a full-blown ClickHouse server or even a cluster. But increasingly, we're seeing CHDB used more. That's ClickHouse embedded directly inside the Python process. In all these cases, ClickHouse is becoming a go-to tool for exploring data sets and transforming data before training. On the right, there's training and inference. And here, ClickHouse plays a pretty important role as a feature store and also as a vector store when taking models, so enhancing the capability of what's been built. And you know, people have been querying databases for quite some time. SQL has been around for a long time, but not much has changed in decades until recently. And with the history of the command line tool, it goes as far back as databases themselves, even before SQL. And you know, if you're like me, it's probably your favorite mode of querying ClickHouse. But while powerful, they've always catered to a more technical audience, people who combine them with visualization tools or programming languages, which means for others it's remained rather inaccessible. You can see here that the users are having to type their commands and run their queries, maybe having to hit the up button if you're familiar with this UI pattern, and having to read data and make sense of it. So this is quite a slow and laborious process for many. And somewhere in the 1990s, graphical interfaces in the web brought a major shift in how people interacted with databases. Instead of typing SQL commands through the terminal, users could now query, filter, and visualize data through dashboards and web apps, tools that with a much broader surface area and far lower technical barriers. And this was the start of data becoming accessible for everybody, not just engineers. And in the last couple of years, we've seen the rise of chat interfaces, an experience that in many ways emerged almost by accident. And just like that, AI went from a specialist tool that that only a few could talk to anybody could talk to. And we're all familiar with messaging apps, but now, instead of chatting with another person, we're chatting with AI models and agents. We've seen this graph earlier. So in the classic real-time analytics model, users interact directly with the system. They submit a query and get a response. So that's one request, one response. Sometimes there's a middle layer in between, such as a language driver, but fundamentally, it's a one-to-one interaction between the user and the database. And we've seen this slide from Marta earlier, which, of course, being the real-time data warehouse, we know what it means to do real-time analytics. And this means always fresh, blazingly fast queries and scalable to thousands of users. But in an agentic context, something changes. We have to scale to millions of agents. And with that, that's where agentic analytics enters the chat. In an agentic flow, the difference is subtle but powerful. Instead of writing a query, you simply express a question, and that triggers an analysis. This shift has been made possible by a new generation of reasoning models that can plan and think through problems. In agentic analytics, the modality changes. One question, one prompt can now trigger 10, 15, 100, or even 1,000 queries under the hood. We really don't know up front. It really depends on the complexity of the request. From the database's point of view, that means getting hit hard with a large, rapid sequential burst of queries, all spawned by one single user prompt. Now think about what that implies. Let's say the underlying database isn't ClickHouse. It's something that responds at 1 minute latency scale. If the underlying queries are like 15, 20, and they're taking 1 minute, then your agent isn't going to finish until 15, 20 minutes later. And that's just not an interactive experience. So as it turns out, the same qualities that make ClickHouse great for user-facing analytics also make it really good for agentic workloads. That's interactivity, high-performance querying, low latency, and the ability to handle massive concurrency and serious read-write throughput. Of course, we all know these. Now, there's simply an agentic layer between ClickHouse and the user, and that layer can trigger a lot of queries, especially as we see more autonomous agents emerge. With that in mind, let's take a look at what we've been building, a demonstration of how both powerful ClickHouse and the AI agent can be. So what you're about to see is agentic analytics in action. In fact, it's already been spoiled for you. I actually showed it this morning, but we love it that much, we want to show it again. So the maintainer here is actually here. He's filming right now, Alexei Karefinov. He's a fantastic software engineer, and he's built this. And we've built a couple of agents into our cloud. One is the documentation assistant. That means you can chat with our documentation via an agent directly in the crowd. But notice with this agent, the natural conversation flow that's happening with your underlying data. Queries are being generated, commands are being sent, and it's tried to keep it all relevant. And it generates summaries and key takeaways. And once this is all complete and it generates some graphs for summarization, you can retroactively go through and inspect the queries, build applications out of it. And yeah, we're seeing a lot of success with this in the product. Out of curiosity, who's using this today in their workflows in ClickHouse Cloud? Okay, I bet that number is going to be significantly higher this time next year. So next is where new protocols are emerging, such as MCP. We've heard about it a couple times today. And MCP is an emerging standard that lets AI applications securely connect to external tools and private data sources, things like databases such as ClickHouse, file systems, and live service data. And at the start of the year, we released our open source Python MCP server, giving developers a simple way to integrate ClickHouse with agentic systems. In short, MCP gives models a structured permission bridge to the real world. And this is where things get exciting, because it opens up entirely new capabilities. A fully hosted MCP server built right in ClickHouse Cloud, which we released last month in September 2025. It's completely managed, no infrastructure to set up and maintain, and secured with OAuth for safe access to your private data. And this now allows us to extend beyond database analysts with our AI experiences in the cloud. It unlocks rapid development for engineers, making it easier than ever to build AI-driven services on ClickHouse. You can connect agents, run complex analytics, and interact with live data, all through a high-performance ClickHouse function. And here, I'm going to demo that. Oh, we'll go back. So here we can connect to MCP. Via the ClickHouse Cloud, you have to enable it. This is available now for everybody in the room. You select your endpoint for your service, and you connect it to your favorite agentic coding tool, whatever that happens to be. In this case, it's just Cursor, but it could be Clock Code or whatever. And here, the developer's working on some sort of live dashboard for that London price data. And they can start interacting with their ClickHouse database and tables directly from their editor. So they've decided to extend this application with some more charts, and they're asking this remote MCP server to run a whole load of tools, to just get organization, list tables, run queries, and here it returns back a whole load of interesting data about what's going on. And then the developer is saying, based on the queries above, add bar charts to the bottom of the dashboard. And then agentic coding tools, what they do best is they start spitting out JSX, which happens to be the language it's using to interact with this React dashboard. But here we can see that it's updating it. And something that might have taken maybe a couple of hours is now taking a couple of minutes. So we've been trying to introduce new features like this to get people even more productive with ClickHouse. So we've kind of moved on from DB analysts, developers, and as we can kind of continue, we want to make these lower the bar so much that you no longer have to be a technical person to interact with ClickHouse. You can be, a business user exploring insights, operators managing systems, or just applications we haven't even conceived of yet. And ClickHouse is no longer where the data lives, it's where the intelligence happens.